Before the advent of modern refrigeration, people relied on natural sources of cold to preserve food and stay comfortable in hot weather. Ice was a precious commodity harvested from frozen lakes and rivers during the winter months. Large-scale ice harvesting became a thriving industry in the 19th century. Workers used saws and other tools to cut massive blocks of ice from frozen lakes and rivers. These blocks were then transported by horse-drawn wagons and insulated with sawdust or straw. Ice houses, specially designed structures with thick walls and proper insulation, were used to store the ice throughout the year. While effective for the time, ice harvesting was labor-intensive, seasonal, and dependent on unpredictable weather patterns. The limitations of natural ice spurred the search for more reliable cooling methods. Enter Dr. John Gorrie, a physician from Florida who recognized the need for artificial cooling in hospitals treating patients suffering from malaria and yellow fever. In 1851, Gorrie patented a machine that produced ice by compressing and expanding air. Gorrie's invention laid the foundation for modern vapor compression refrigeration systems. His machine worked by compressing air, which generated heat. This heat was then dissipated, and the compressed air was allowed to expand rapidly. This expansion caused the air to cool significantly, enough to freeze water and produce ice. While Gorrie's invention was groundbreaking, he faced financial and technical challenges that prevented him from commercializing it widely. Despite the setbacks faced by early pioneers like Gorrie, the late 19th century witnessed significant advancements in refrigeration technology. Engineers and inventors continued to refine the vapor compression cycle, making it more efficient and practical for commercial applications. The development of reliable refrigeration systems revolutionized the food industry. Refrigerated railroad cars and ships enabled the long-distance transportation of perishable goods. Meatpacking plants, breweries, and other industries benefited from the ability to preserve products for longer periods. Refrigeration extended growing seasons, reduced food waste, and made a wider variety of foods available to consumers year-round. The impact on public health was also significant, as refrigeration helped prevent foodborne illnesses. The early 20th century saw the gradual adoption of refrigeration in homes. The first electric refrigerators, while expensive and bulky, started appearing in affluent households in the 1920s. These early refrigerators used toxic and flammable refrigerants, making them potentially dangerous. However, continuous improvements in technology and the introduction of safer refrigerants like Freon in the 1930s led to wider acceptance of home refrigerators. Around the same time, air conditioning began to emerge as a technology capable of transforming indoor environments. Willis Carrier, considered the father of air conditioning, developed a system for controlling humidity and temperature in 1902, initially used in industrial settings like textile mills and printing plants. Air conditioning gradually found its way into theaters, stores, and eventually homes. The invention of the window air conditioner in the 1930s made cooling more accessible to the masses. The development of Freon, a chlorofluorocarbon or CFC refrigerant in the 1930s, was hailed as a major breakthrough in refrigeration and air conditioning. Freon was non-toxic, non-flammable, and highly efficient, making it an ideal replacement for the dangerous refrigerants used in earlier systems. The widespread adoption of Freon led to a surge in the production and use of refrigerators, air conditioners, and other cooling appliances. For decades, Freon was considered a miracle chemical, enabling unprecedented levels of comfort and convenience. However, what was not known at the time was the devastating impact that Freon and other CFCs would have on the ozone layer, Earth's protective shield against harmful ultraviolet radiation from the sun. The discovery of the ozone hole in the 1980s brought this issue to the forefront of global environmental concerns. Scientists discovered that CFCs, once released into the atmosphere, could travel to the stratosphere and break down ozone molecules. This depletion of the ozone layer raised serious concerns about increased risks of skin cancer, cataracts, and damage to marine ecosystems. The ozone hole, a region of severely depleted ozone over Antarctica, became a stark symbol of the unintended consequences of human activity on the environment. The discovery of the ozone hole and its link to CFCs spurred a global response. Governments, scientists, and industry leaders recognized the urgent need to address this environmental crisis before it caused irreparable harm to the planet and its inhabitants. The Montreal Protocol, signed in 1987, is considered one of the most successful international environmental agreements in history. The treaty set forth a timetable for phasing out the production and consumption of CFCs and other ozone-depleting substances. Developed countries agreed to phase out CFCs more quickly, while developing countries were given more time to transition to ozone-friendly alternatives. The Montreal Protocol's success can be attributed to several factors, including strong scientific consensus, international cooperation, and the development of viable alternatives to CFCs. The treaty's provisions led to the rapid development and adoption of hydrofluorocarbons, or HFCs, as refrigerants. While HFCs do not deplete the ozone layer, they are potent greenhouse gases, contributing to climate change. The recognition of HFCs' impact on climate change has led to a renewed focus on developing and deploying climate-friendly cooling technologies. Natural refrigerants, such as propane, ammonia, and carbon dioxide, are gaining traction as viable alternatives to HFCs. These natural refrigerants have a negligible impact on the ozone layer and significantly lower global warming potential compared to HFCs. In addition to transitioning to climate-friendly refrigerants, the cooling industry is exploring innovative technologies to improve energy efficiency. Variable speed compressors, advanced insulation materials, and smart controls are just a few examples of how manufacturers are reducing the energy consumption of cooling appliances. These advancements not only benefit the environment, but also help consumers save money on their energy bills. The rise of smart homes and the Internet of Things, or IoT, is creating new opportunities for optimizing cooling systems for maximum efficiency. Smart thermostats, for example, allow homeowners to program their heating and cooling systems based on their schedules and preferences. These devices can learn a household's patterns and automatically adjust temperature settings to minimize energy waste. Some smart thermostats can even connect to local weather forecasts and adjust indoor temperatures accordingly. Integration with other smart home devices, such as occupancy sensors and smart blinds, can further enhance energy savings. For instance, a smart cooling system can automatically turn off the air conditioner when a room is empty or lower the blinds to reduce solar heat gain. The refrigeration and air conditioning industry is constantly evolving, driven by technological advancements, environmental concerns, and changing consumer demands. The future of cooling will likely be shaped by several key trends, including a continued focus on sustainability, increased connectivity and intelligence, and a growing emphasis on personalized comfort. The development of even more environmentally friendly refrigerants with ultra-low global warming potential is a top priority. Artificial intelligence and machine learning will play an increasingly important role in optimizing cooling systems for maximum efficiency and performance. Personalized cooling solutions, such as wearable devices that regulate body temperature, could become more commonplace. As the world grapples with the challenges of climate change and a growing global population, the refrigeration and air conditioning industry will continue to innovate and adapt, ensuring that the future remains cool, comfortable, and sustainable. Hit that like button, subscribe, and stay informed.